Okay, hello students. This is Unit 4, Lesson 15. Using graph and logarithms to solve problems. So there are two chapters. One is Lesson 4, 15, and then 16. Both are about how to graph and solve logarithmic equations. So here I'm going straight away to the practice problem number 1. At the same time, I would also like to show what is the learning target here. So the learning student facing is this. Let's use graph and logarithms to solve problems, and I can solve exponential equations using logs or graph. So I'm gonna straight away dive to the practice problem, and that's the first problem right here. Is Unit 4, Lesson 15. So first, I want you to try see if you can figure it out by yourself. So pause the video for a while and see if we can try this. Question number 1, the equation, exponential function is given or equation represents bacteria population as a function of time. So x-axis input is, this is the input is the x-axis and the output is the population right here in thousands. So these numbers are in thousand, even though if this is 120, it's thousand, it means it is 1, 2, and then 0, 0, 0, 120,000. That's what this number means. Now, by just looking at this, question is use the graph to determine, to know when the population will reach 100,000. So what does 100,000 means? We have to just look for output as 100. So this is the output of population of bacteria, and you can clearly see I use a different color here. So the number 100 is here, right? 100,000. So you go this way, that's the output. You go all the way until it touches the number here, right here. And then you go down. So you go down this way, and this is like approximation. So you go all the way until maybe somewhere here. And it is exactly almost like halfway down between, but it will move closer towards somewhere here maybe. And I'll just make it maybe 4.3. So if I write 4.3, it means it is 4.3 hours. Then the second question says, explain why logarithm 20 to the base 2 also tells us the population will reach 100,000. So what you get, this is where you have to solve the equation. So the output is, so in this case, so it's like 100,000 is the output. This will be the population of bacteria. We want to, so the question, when will it reach 100,000? When? So, and the model exponential function is already given to you 5,000 2 times h, and by just looking at it, this exponential function, you watch two things, that this is the growth factor. That means each hour it doubles. So what does this means? It is 1 plus 1 is whatever the 100% of the original remain, and then also it adds 100%. 100% is 1. So that's why this is today. So every time it doubles. So whatever the population in the beginning, if you see, this is what you had in the beginning. It says it is 5. So this number is 5, but over here it is 5,000. So that's the beginning of what the bacteria population was. So now the second question is saying, okay, so does this really mean also how many hours? Let's work it out. Now this, if you first set it up and then divide by 5,000, so both sides, you can see you get, so this 5,000 goes away, this uh, sorry, 5,000, this 30 will go away, and 5, see this part, that will be 20. So what did we get is, we get this 2h, so 2h is 20. And remember, when you want to change this exponential form to logarithm form, so we want to convert this to the log form. To convert the log form, you look out for the base, and in this example, the base is right here. This is the base. The 2 is the base, right? So when you write in the log form, the 2 is written at the bottom, and whatever the output here become the input here, and this h, which is the exponential, this h, this h will be, this h is the input for the exponential function, this one. So this becomes h, you see, and you're done. So basically what it means is logarithm to the base 2 of 20. It means how many times do we multiply 2 to go all the way to 20? And you can clearly see basically what it means is how many 2's do I multiply to get 20? And you can see it says 2 raised to 4 is 16, and 2 raised to 5 is 32. And you can clearly see this 20 is between 16 and, so the numbers is 4 and 5, and 20 is more closer to 16. So that's why it's almost like between 4 and 5, but more closer, so which is 4.3. Hope that takes care. So the second question, we need to use technology. We will use Desmos.com, the population of United States from 1800 to 1850. That's like 50 years. And in millions can be modeled, it is represented by this function. So what we do is we see what, even before even we post it in the desmos.com. Basically, we also need to understand what is the meaning of each of these numbers. See this part. So what is this basically means? In the 1800, this is 5 million. So this is 5 million. It means 1800 is considered like if you want to make a table like that. Okay. So the top part, let's see, in the beginning it is 5 means 0. That means this is 1800. That's what that means. And because in the year 1800 we consider like a 0 year, and this is, instead of writing 6 zeros, I just write 5 here. So this is let's see, this is time, years since 1800, and this is f of t. So then it goes on, and until it says maybe somewhere here is 1850. So this means this is 50, right? So the question is, what was the population in 1800? So by just looking at it, the first question you already answered. You see the number here. You always compare with the function, exponential function. When the growth rate is calculated continuously, so whenever there is e raised to rt, okay, so that's where you compare the exponential function with the base e. So this is this one. So this a is this part, 5 million, and this r, this is c, is the growth rate. So this r is the growth rate. So the r is 0.028. When you multiply 100 and divide by 100, 28%. That means the growth rate each year. This means the growth rate every year is 2.8, but calculated continuously during the whole year. That's what that means. So I wanted to make sure we understand what is this coefficient of t means. It is basically, it is the percent increase every year. But this e, what does it do? It means you are calculating each moment every seconds, not just once in a year, but every day, minutes, 60 seconds. So let's go. Is ask you to graph this, and you can see this number. We have to change the window to 100 for x and 0 to 44. So, and then he's asking us, what is this y equal? Adjust the graphing. Use graphing technology to graph this. So we have to graph two parts here. So here you're going to graph two things. One is this whole thing, whatever that's given to you, and also you have to write this like a line, right? Why? It's like 20 million. So we just want to know when is the population will be 20 million. And let's graph. And what is the intersection point of the two graph? What does it mean? So let's go directly to the Desmos. So let me click here. So in the first case, we'll write it's given as f and t. equals 5 times e to the power, and we multiply 0.028, 0.028, multiply by t and close it. So we have the graph. That's the first one. And also we put another one is y equals 20. So now the thing is we can't see the whole graph, right? So we do some adjustment here, changing the scale. So the first one says it's from 0 to 100, so it's like 100 years. And the bacteria population, sorry, the population of United States from 0 all the way they gave us 40. That's like 40 million. Okay, here's the graph and clearly see. I'm gonna take even though, okay, so you can see that's like 20 million. This is the line, and this is the graph. You can see as the years pass by since 1800, and there's one point where they meet. So what does that mean is 20 million population is when it is 49. So what does this mean is it's approximately 49.5. It's like 49 and a half year, almost like I'll round it to 50 years. So about 50 years after 1800 or in the year 1850, so this means in 1850, the US population was 20 million. That's all that means. So that's it. So you had, they did ask us, question number B was just graphing. And after graphing, question number C is asking what is the point of intersection of the two graphs? And what does it mean in this situation? So in this means the point intersection represents is is like a common point when the population will be 20 million. So, and you can clearly see that after almost 50 years since 1800, and then this is like you add 50 to 1800, so it become 1850. The population was 20 million. That means 20 and then 6 zeros. So that's what that means. I hope so here, so it means I should write. So it will be 49.511, which is approximately 50 years. So that means the 1800 was the original. You had 50, so it's 1850. The uh, population was 50 million, which is 50 times, and you put 6 zeros, and that's like the actual number. Hope that helps. Okay, the third question is the growth of a bacteria population is modeled. So you have another exponential function given, and there's a e means so that means it's growing every moment. For each question, explain how long does it take for the population to double. So we want to know when will this be double. Now remember in the beginning it was 100, it was 1000. Okay, so if I draw this in the beginning, 0 hour, that means h, and this is the population after h hours, it was 1000. So then what they gave is there is a rate function. See this? The growth rate is 0.4, which is 40%. Okay, so it's like if it is 40% means every hour. If I want to know calculate 1 hour, 2 hours, so that would be you just multiply here one because this is 0.4. So if you want to know every hour, it will be 1.4. So that's the growth factor for each hour. It is 1.4. But remember this function we are calculating every moment. So question is asked when will this be 1000? So you cannot we cannot do this way like 1.4 multiply again 1.4 multiply again. No, this won't help because this is a continuous e is there. So every second this is happening. So we need to use different way. Use solving equation. That's what is the how to solve equation basically means when the population will be double. What is double basically mean? Instead of 1000, the population pH. So we want to know pH when the output will be 2000. That's the double, right? So what we do is we'll write in replace pH here. You replace pH here. 2000 equals 1000 times e raised to 0.4h. See, and this is what you solve, solving the equation containing exponential expression. Now here to solve this, best is divide by 1000. Okay, this goes away and this 30 goes away, and you get e raised to 0.4h equals 2. Okay, and then you change this to the log form. So how do we change this to the log form? So when exponential is written in the logarithm form, so I'll write logarithm. Now this is the output, so that goes off to, and the base is the e, so we put a e right here, and this is the input will become 0.4h. Okay. Once you get this, this is also written instead of log whenever there is a e, because a natural number, we use ln. So ln of 2 equals 0.4 into h, and then divide by 0.4, 0.4, and this 0.4 get, and you get the answer. Now, how do we figure out this? We have to put in the, this we'll have to put this in the calculator. So, so ln of 2 divide by 0. Let's check it out. And so using the calculator, we can figure out, let me see, get the ln. From here, you can see, click here, go all the way down. And you see there's a ln, and you have to put ln of 2. And then whole thing divide by 0.4. I think I forgot to put a point. See? So you get answer as 1.732. So that means almost like, so what does this mean is about, now this is exactly 1.73 hours. So there's another way to do is also we can graph this. Let's see if we can graph this, whatever the function is. You say pH equals, I put 1000 and then e to the power 0.48. And now we'll have to do some adjustment here, because you want to know where is 1000, right? So we have to change this 1000 to maybe 3000. And because x, there are too many hours here given, so that I will make it maybe 10. Okay. And then, so not even 10, we just make it less. Maybe let's put it like 6. Okay. So you see this is the graph of, so you can also trace it to know exactly, the question was when will it be 2000, so you can go this way and see the number, second number changing, and see when it is closest. You can think 2000 here, 2005, little less, little down. That, I think that's close. So that happens like 1.71. So this way you can trace and get the answer, right? And then another question is, instead of ln, the B part is when will the bacteria population will be 1 million. You can do the same calculation that I showed, and instead of this ln of 2, so when you divide, let's go back here. We see this instead of, so if it was not double, let me write the same again. Okay, so instead of when will it be 1 million, right? So you put a 1 million equals 1000 for h, and this time you divide 1000, and this goes away, and everything, all the steps remain the same like what we did earlier. The only change is the h will be ln of 1000 divided by 0.4, and this is what you put in the calculator, and we can find out. Let's try to figure it out. Instead of, I'll put ln of 1000 divide by 0.4, and you get 17.2 25 or 26 hours, and that's it, and you're done. So hope that helps. So you do the calculation and figure it out. If you want to really so see here, we'll have to change 3000 to maybe 1 million something. So we'll put 1 million, 1 2 0 and 0, and then another thing, see. So you can do like this and get the answer also. But then we'll have to do a lot of, because I did not show. So when that will happen, 17, I have to adjust this to 20 maybe. This one will be 25, let's say. And this I want to write 1,200,000, let's say. 1 million. And then I have to put y equals 1 million. See? And you can clearly see that's the point. So this is the point where after 17.26, the population of the bacteria will be this one. So this is so cool to understand. And there's one more shortcut trick I'm going to show you later on, and that is let's see, whenever there is a y equals a and e raised to rt, and suppose you want to know how to figure out. Let's see, there is a y1 here, something y. I will put this as y1, and somewhere around y2. So they may ask you, when will this be? This will be given. This also will be given. So question is, and this a is known. So this is known. This also is known. This also is known. So how do I find after how many hours? And you have a shortcut formula. Just remember that t basically becomes equals ln of y2 divided by y1. If you see the calculation that I did, and just divide by r, and you're done. So that's the shortcut trick to remember, that you just have to divide this two. You divide the output, the second one, divide by the first one, take the logarithm of that ln, and then everything divided by r. Or it could be other way around if you want to know r here, this whole thing also. So this one, if they ask you what is the growth rate every year, then this same formula changes to this way, y2 divided by y1 and just divide by t. That's it. And you know the growth rate. Question number 4, what value of b makes the equation true? So what all you do is, let's say the first one, they gave us the logarithm form, right? So the question is, how many times this base, we need to know how many b's do you multiply like this all the way. It's already told you b has that number, whatever this b has to be multiplied twice. The answer is already given. So what should be that b when you multiply? You get the answer is 144, and most of you know what is that number, right? So if you don't know, we will just put it b square. Of course, common sense, we know 12 times 12 is 144. So we can straight away use mental maths and know the answer. But I want you to write from log form. So basically, this is the base which is there. You push this to up and you put it up here, and then you write this number which is 144. So just imagine you did not know what was this b. If it was something different, if this number was some 153, then you have to write b is square root. So put square root of this 144, which is also 144 raised to the power 2, which is the square root of 144 is 12. So you get directly answer. So my question was, let's do the second one. How many times, what number? So the second one is b raised to 2 is 64. And of course, so you already know what's the answer. It has to be 8 times 8, and that's the answer. What about this third one? So again, this time it will be b. So this is b raised to 3 gives you 64. Now what? So again the same thing, 4 times 4 times 4, right? So that gives you 64. So it is 3. What about the next one? This one, the fourth one is b raised to 6 is 64. And sixth, it's like sixth root of 64. Or you will just use your common sense and say, hey, you have to multiply 6 times. See? So if you multiply 6 times, 2 times 2 is 4, 4 times 2 is 8, 16, then 32 and 64, and you're done, right? And the last one, be careful with the last one. So what we do is, this part is base is b raised to minus 2 equals 1 over 9. Now see, this is there's a fraction, right? I'm going to write this as changes to positive, so it becomes 1 over b raised to 2 equals 1 over 9. So the top numbers are 1, so this b square has to be 9, so b has to be 3. So if you see question number, this is from lesson number 10. If you miss that, this will help you. Now, how do you write from the least to the greatest, the smallest to the big? Now, see that is, so that I'll just put like this. So kind of making a little work here, each one. So let's see what is this answer basically means. It says log 11. So we do know 2 raised to 3 is, so how many 2's do you multiply to get to 11, right? 2 raised to 3 is 8 and 2 raised to 4 is 16. That means this thing has to be, so 2 raised to what number? So 2 raised to what number? It is like 11, so that means this is the box. And remember, this number will be between 2 raised to 3 and 2 raised to 4. Because 2 raised to 3 gives you 8, 2 raised to 4 is 16. So we want to know what is this? So we just say, hey, the number is between 3 and 4. So this answer will be between, this thing will be between, I will write 3 and 4. So not exactly, but between 3 number. What about here? The base used is 3, right? So if the base is 3 and 3 times 1 is 3, so 3 times 1 is 3 and 3 times 2 is 9, correct? But there's number 5. So how many 3's do you multiply to get to 5? So we're asking what is that in the box to give you 5. And you can see this 5 is between this 3 and between this 9. So your answer has to be between 1 and 2, since part. So this log will be between, so I'll just write 1 less than logarithm of 5, 3 and less than 2. So this is the 1 and that's the 2. And I think I forgot here, this is between 3 and logarithm of 11 to the base 2 and 4. Let's do the next one. And this is straight away serious because 5 raised to the power is 25. So you're done. So this value is already this. How many times do you multiply 5 to get to 25? So that's 2. Done. How many times do you multiply? Here the base is 10. How many 10 do you multiply to get to 1000? You can clearly see they have to be 3 of them. So it is 10 raised to 3 is 1000, right? So the answer is this 3. So that's 3. The last one here is, how many times do you multiply 2? So 2 times 2 is 2 times 2 times. So let me write it in another way. So 2 times 2 is 4 and 2 times 3 is, so this is 4 and this is 8, right? And this is 5. So the 5 is between this, right? So that means the 2, which is the base here, 2. So this value has to be between 2 and 3. Because to get to this, it has to be between 2 and 3. So we say, okay, this value is between, it means so the logarithm of 5 to the base 10 is between 2 and 3. Now you can see which one is the smallest and which one is the highest, and you can clearly see This one is 3 and 4. So now you decide which is the smallest among this is, if you see this, this is between 1 and 2. So this is the smallest. That's the first one. After that, there's a 2. So that goes this one with the 2. So this one's the second. I will say this is the first on the left, and this is the second. And then there between 2 and 3, this becomes log 2. So there's a okay, again I repeat. So this is the first one between 1 and 2, right? So that's the first. Then this is exactly 2. So this is the second. And next one is this is between 2 and 3. So this becomes the third. So that's the third. And then comes the 3 which you had here. See this part? This was 3. So then comes this one. And finally the big one, even though this is the big one. This is the last one, the fifth. So I hope that makes sense to you. Okay, this is how to do this. First step is you just divide by. So it is given 9 times 10 raised to 0.2 t equals 900. So divide by 9. This will be 100 up there. So 10 raised to 0.2 t is 100. But 100 can be written as 10 squared. So I'll take this off and put a 2 right here. Now they have the same bases. So if the bases are same, then the exponent has to be equal. 0.2 t equals 2. And then divide by this and you get the answer. So you multiply 10 and you get 20 divided by 2 equals 10 and you're done. Yeah, so this part is less than 4. So 2.7 is less than 4. So the number, this one is less than 4. But if you square, you see it is greater than 4. So that means this has to be between this one and this two. But if it is 1, it is 2.7 and which is less than 4. And if it is 2, then it is 4. So actually the exponent which is right here has to be between 1 and between 2. So I repeat one more time, little confusion. So first is we needed to know how many times do you multiply 2.7 to get 4. If you put 1, you get a number 2.7, but that is smaller than 4. Okay? Smaller than 4. And if it is 2, that means we get this number. This is greater than 4. So, and that's the reason we say this thing has to be between 1 and 1, 1 and this one and this 2. I hope that takes care. Okay, so this completes the unit 4 lesson 15. Okay, very soon I will be also making practice problem for lesson number 16.